This is the Anatomage Table. It is 87 inches long, 28 inches wide, 34 inches tall. The screen is 22 inches wide and 81 inches long, which allows for life-size, full-body anatomy interaction. The system weighs 500 pounds, but is placed on 4 casters equipped with brakes. This allows for mobility and stationary use. On the front are 3 USBs for uploading your own DICOM datasets. On the side is access to the RJ45 port for connecting to your network. There is also access to the power source. Currently, the Anatomage Table operates on 120 volt, 60 Hz standard. This is the Anatomage Table, an interactive display system for anatomy education. It is capable of providing full-body anatomy at a life-size scale. At this scale, anatomy has a stronger presence and provides a more direct and responsive experience. The form factor allows for multiple people to stand around the table and interact because it simulates an operating table. In this way, it strengthens a collaborative learning experience and provides a feeling of being in front of a real cadaver or a patient. The touch interactivity is natural and intuitive, again strengthening the idea of being in front of a real patient or a cadaver. We started with a medical CT scan data of a live patient. We then added in digital models on top as an educational tool. What we're seeing here is the skin model that we added on top of the volume rendering. As I rotate around, I can use our scalpel tool and create our own custom cutting plane. And so now when I rotate, I can actually see the volume directly underneath with the digital model. Pressing this again will return the volume. Pressing this icon allows us to change our renderings and to adjust the models independently. So as I hide the skin, I have now the skeletal system showing. And this way you can actually see all the other models that we've added in here. As you can tell, we have the circulatory system, the nervous system, as well as the digestive organs, all modeled directly on top of the 3D anatomy from the medical CT scan data. Bringing up this dialog again, as I adjust the contrast and the brightness values, I can actually start to show the musculature underneath. Pressing the scalpel, again, creating my own custom cutting plane. I can rotate around and look at the internal structures there as well. We also have the ability to mimic X-ray renderings. So if I click on this icon again, choose the X-ray, and I adjust the brightness and contrast, you begin to see how we're relating radiology with general anatomy. And if I don't want to see the digital models on top, I can turn them on or off independently or hide them all with a single click. And again, this is still interactive, so you can rotate around. Lastly, we have our annotation feature, where we're able to turn on interactive annotations directly onto the volume. These annotations are fully customizable, so you can have them cater to a specific course or replace all the text with numbers for an examination. The table also allows you to open up your own DICOM datasets, which means you can load in your own CT or MRI radiology scans. When you do that, you're still able to interact with it like you were before, rotating it in an intuitive way. Pressing on this allows us to adjust the brightness and contrast like before. Here we're bringing in the musculature and looking at the upper limb. With the use of contrast media, this could be a very effective educational tool. And again, with our scalpel tool, we're able to create our own clipping planes and rotate around to see internal structures again. Here's another example of loading in your own DICOM dataset. As you can tell, this patient that was scanned has a pretty bad femoral fracture and their legs being held together with a surgical brace. Clicking on our scalpel tool, we can cut away some of the volume and start to look at it in a different perspective. And again, we have the ability to create our own X-rays, adjusting the brightness and contrast. This is our last case of opening up your own DICOM dataset. Using contrast media, you're actually able to see the blood vessels in the scan. Using an axial cut, I'm going to cut through, actually start to see the vessels within the head.